How to decrease the cost of operation of lift stations. I made a lot of volumetric flow meter during my lifetime. One of them made me discover that 1/3 of lift station had daily intermittent electrical problems that were affecting volumetric flow calculations. Later on in my life, I continued to develop other products, and one of them made me discover that 1/3 of electrical equipment had intermittent electrical problems. So one thing I've learned with this one is that electrical problem degenerate to the point where they can be discovered. When we calculate flow, you need to compensate for abnormal behavior. It's not just volume divided by time. That would be what I did back in the early 1980s. So you have to do something different when you want to compensate for abnormal behavior and if you want to have high accuracy. One thing I did not too long ago, I decided to analyze pumps within over 150 lift stations just to figure out when there was a difference in pump capacity, what was the difference in pump run time, and arrive with a rule of thumb that for every percentage difference in pump capacity, you had twice that difference in pump run time. So if you can increase the pump capacity by only 5%, you will decrease the pump run time by 10%. The key here to be able to reduce the cost of operating a lift station, other than finding problem earlier, is that when the flow rate is low, run the pump at the highest possible level of operation within the lift station. When the flow rate is high, run them as low as possible. Don't wait to reach the lead level to operate your pump for 2 hours when the flow rate is high. Start the pump way earlier so it will take more time to get the lag level where both pumps start and the efficiency drops quite a lot. That's the solution. How to implement the solution? First, you need to have flow in real time, not at the end of a cycle for the cycle before. You need to have this in real time. It needs to be able to compensate for abnormal behavior, and it needs to be able to handle soft starts and soft stops. There are few things. If you can connect a level sensor, then it will also check if the level of operation are always the same, if if it varies, or if you have any kind of abnormal behavior like level dropping without any pump running. This is the cheapest way of operating lift station, but usually it's because you have a siphon effect or the level sensor is defective. In both cases, it's bad. When you have a defective level sensor, it looks like something like this. This came straight out of a lift station with a SCADA system, top-notch SCADA system, that didn't discover anything abnormal in that lift station, by the way. Okay, even if all the pumps were starting together at the same time, like every 8 seconds for hours in a row, it was not enough to create an alarm. We have a test bed in Florida where we have a 7 lift station where they are analyzing data right now to see how much money they will be saving using a flow-based operating system. In their case, when the flow rate is low, they can increase as an average the level of operation of their pumps by 4.25 feet. In their case, the average increase in pump capacity because of the change of head is 17%. So increasing the pump capacity, that means it will reduce the run time by about 34% when the flow rate is low, which is most of the day, by the way. By reducing the pump run time by 17%, that means the electrical costs, maintenance, and wear of everything is down by 34%. I made a spreadsheet to help you calculate what kind of benefits you could get out of your own lift stations. You can download it from that small link that you have on the bottom here. I'll show you now how this device can be installed. Okay, in lift station, when pumps start and stop, of course they are using current, and which is proportional to the size of the pumps. With current, you know when the pumps start, you know when the pumps stop, you know how much electricity they are using. When the current start, that means the pump starts. When the current stop, the pump stop. If you know the volume between the start and stop level, you know the volumetric flow in and out of that lift station. If you to the level sensor, then you will just check the level when the pump start and when the pump stop, and you will be able to calculate flow rate. In this case, what I'm showing right now is that to install this device, it's just a matter of putting 1 current lamps per pump. You just connect the device to a wall outlet, and the instrument is connected. And that's all there is. After that, you need to set it up. If you have a level sensor, we suggest to use a current isolator. And so you piggyback on that level sensor, and you have quite a lot of information out of this. As you might have noticed, there's different ways of installing this instrument inside a control panel. When you have a lot of lift station and you don't have a lot of budget, I strongly suggest that you use it in your toolbox and you move it around. If you have a good SCADA system, make sure that it's working properly by cross-checking what you're getting using a device like this one. If you don't have any SCADA system, this can be just the heart of it. It doesn't replace a controller or anything like this, but it monitors perfectly what's going on inside the lift station. Usually it's a 45-minute presentation, so I hope you enjoyed that.